Hey everybody, welcome to another episode of Behind the Cape. I'm data superhero Keith Belanger, and joining me today is fellow data superhero Stewart Bryson. Welcome, Stewart.
Thanks for having me. First time presenter, but long time watcher and listener. So I really love the show, and thanks for having me on.
Now, really excited to have you on today as well. And today's topic, you were going to talk about loading TPC-DI data sets using Snowpark Python. But
Yeah,
before we get into that, do you want to just kind of briefly talk about what is the TPC-DI data set?
sure. So the TPC is a long running organization whose goal is to try to be an arbiter of benchmarks across technology platforms. So they've rolled out a huge series of different benchmarks, OLTP, decision support that shows you the age of this organization. That one of the data sets is called the decision support data set. Just brings back a lot of good memories. That one is actually comes a few of the TPC data sets are public data sets in Snowflake. So you'll see some of those. You might have wondered what they were. The DI data set is interesting because it's designed for benchmarking data integration, ETL, data engineering,
Right.
whatever you want to call it, processes. So if you say I can process a bunch of data faster than you can, well, there's a uh, agreed upon data set, series of source files that and a data warehouse schema that is agreed upon that will be loaded that you can benchmark. I will say what I'm going to talk about today is not about benchmarking. It wasn't really what I was interested in when I loaded this. I just wanted the data loaded.
Right.
So don't take some of these simple Python loading approaches as the best way to optimize for speed and actually measuring the benchmark. That wasn't my goal. It was just to get it loaded. So if you're interested in getting a series of source data loaded into Snowflake so that you can test data engineering principles, that was my goal, and
Yep.
and that's the main point of it.
Yeah, and I have played around with some of that data as well. Like you said, some of it is inside Snowflake already, and I leveraged some of that. But yeah, it is especially when you're trying to do things and you're like, oh, where can I get some data? How can I play around with this? And you want a
Exactly.
good, and you don't want to spend time searching for data. It's a great place to go and leverage if you're, like you said, if you're trying to just test some pipelines or other things that you're
Exactly.
working on in concepts. Great. Well, I look forward to hearing what you got to show us.
Sure.
Do you want me to share your screen?
Yeah, let's do it.
All right.
So just so that no one's weirded out by what they're seeing, so all this is just in a Jupyter notebook, and if you're not aware, you can run a Jupyter notebooks directly within VS Code, and so that's what I'm doing here. So and of course, notebooks are great for all kinds of things. There's my typical QR code which takes you to my LinkedIn. So if you're interested in that, pause it, but I'm not going to stick there too long. So we've already talked about what TPC is, so I won't rehash that. There's a few links for you, and Keith will probably put these in the show notes as well, or the description. But I do want to talk about exactly what this data set is and what it isn't. So you can show this is a diagram, and it's also a little bit dated, but this is a diagram that's in the specification from the TPC-DI data set. And basically what's under test here is these series of extract files. And this actually does line up pretty well with how we did things back in the day when the TPC was coming up with this specification. We did a lot of file extracts. So the idea that we would be loading data beginning with loading files is on point for the time at which this existed. But what's under test here is not the generation of the files. And you can see, actually going and getting the data from the source systems is not really under test. It is simply the loading of the files, the transforms into a data warehouse. And so what I want to show you how these files are generated. So first of all, you have to go to the TPC webpage, register, give them your email, they'll send you a link, and you can download this toolkit. And this toolkit is a Java jar file. that you can execute. And it has to use, I've tried to use this with a later version of a JDK, but it just wasn't having it. So you really need to use a 1.8. Let me know if you figure out how to run it on something later. And so when you run this utility, you see that you got a few command line options. The most important one really is the scaling factor. So you're able to pass a range anywhere from 3, and I'm not going to count what that number is, but it's quite high. And so what all that does is multiply the amount of data that's in each of the files. And so that's really interesting if you want to really test your data engineering processes at scale. Test the warehouse sizes you're choosing, test a lot of the different loading mechanisms and options that you're trying. You can go anywhere from small data to big data. And then within all the files that it generates, we'll just go ahead and kick this off. You see that I'm just calling this jar utility. I'm just going to do a scale factor of 5 because I want things to finish quickly today. But you can see that we're running a bunch of files. We're generating a bunch of files. And what's interesting is there's anywhere from small files that have only 5 to 10 records, no matter what the scaling factor is, because it's really reference data, all the way down to some of these big files, which are things like daily market and watch history, which become the source for some of our fact tables. Those are the ones that really multiply. So now, if you've wandered upon this video and you're like, Stewart, I'm really interested in how you load all this, but really I just want the data set loaded. Well, if you go to my GitHub repo, which also has this notebook I'm showing you, I have created a command line utility in Python that makes loading this easy. So if you take nothing else away from this video, just the ability for you to be able to use a command line utility to load all this data. And the main command we're interested in is the process files. I'll show you what that looks like. And you got several options here. So you got your output directory, which is required. If you only want to load a single file, that's an option. If you want to override the default stage, you want to run a different batch, you want to overwrite, there's just a lot of options there. I'll show you what this looks like if you just want to load a single file. And you'll see a lot while I'm going through this demo is you'll see a lot of the file uploads that say skipped. And that's because with the Python put command, by default, if the file is exactly the same that you're uploading, it just simply skips it. So don't be alarmed when you see a lot of this saying skip. That's on purpose. It just gets us to fly through this quicker. And so you can see this is one of the sample files, and this is what it looks like. So if all you want is to load the data, check out that Git repo. There's a nice README that walks you through it, and you should be fine. But what I really wanted to do in this, Keith, is talk about some of the challenges in loading this data set. Some of these challenges should not exist anymore, such as fixed width multi-format files, which I'm going to show you. XML, not quite so common these days, but nonetheless, these are challenging approaches for folks today. And I wanted to walk through how easy that is in Snowpark.
And what, even reviewing, it's not common these days, but organizations who might still have some really large legacy mainframe platforms and other things like that are still looking to modernize are probably still having to handle and deal with, XML based files and stuff like that.
Exactly.
So, yeah.
And it's a good point because if you're in the modernization process, even if you're writing one-off conversions or migrations, Snowpark's going to really come in handy because it can handle these things.
Right.
And with mainframes are exactly where these fixed length multi files come from generally. That was a main way that data was transferred between systems back in the day. So I'm going to walk through some of the code samples. All the code samples you're going to see are sort of snippets taken from the loader that I showed you earlier, with a lot of the abstractions removed, so that it's easy to follow. So we start with a credentials file. So I just made a very easy JSON file, which has all of your credentials in it. And you can see what this looks like. We just simply load that file. We pass it as a dictionary into the session builder, and this will give us a Snowflake session. So right now I have a Snowflake session. I've made the connection, and we're good. The first thing I want to demonstrate is what the majority of these files are similar to CSVs, except they're pipe separated. Is that PSV? I don't know. But then instead of a comma, it's a pipe. So I'm going to show you the majority of the files are that format. And this is dead simple for Snowpark. So we'll upload the file. You'll see that again skipped because it's already there. And then this is how we will take a very simple CSV or PSV, if that's right, and load it. You can see the one thing, if it's a CSV, that you would eliminate is you wouldn't have to pass a custom delimiter. And also for most of these, I'm doing an overwrite. That means I'm not going to append on the end. I'm going to rip and replace the table as a whole. And you can see I'm going to create this data frame, read it in, pass the delimiter, and then save as table, which is really, really easy. I mean, SQL isn't really, SQL's, obviously you have create table as select, but for you to do loads and other things, it's not as simple. Snowpark makes it dead simple for you to take a file and create a table out of it. And let's take a look at our results here. And this is our table. So you can see I've created a new data frame. I'm just grabbing the same table name that I had before, which is daily market that I created. And we can see a sample. And that's the same one I showed you earlier with the loader. So now moving on from the CSV/PSV, I'm going to show you these, what's called thin-wire files from the specification. So what these are those fixed width multi-format. And I think that'll make sense what I mean by that in just a minute, because I'm going to show you a sample. So what we're going to do is we're going to load a whole series of these files, and you'll see why that's important in just a second. So I'm globbing. This is just a Python library that makes something like this very, very simple. I'm going to glob all the files that match this pattern, and I'm going to put all of them and see our results. So I won't make you watch all of these. There's quite a few, but notice that what these files represent is historical data pulled from the markets. And there's one file for each quarter for multiple years. And I want to show you what that file looks like so that you get, hold on one second. This has got to, unfortunately, that has to finish uploading all those files. So I'll take a quick question if you got one, Keith.
Well, more what I'm kind of in my head is you brought up how Snowpark is making loading these, being able to do this exercise so much easier. I'm going to go back when, oh God, I guess it's already almost like 5 or 6 years now, when I first was trying to load data into Snowflake, for when I was starting to get into Snowflake and trying to bring data in. And, you know, I thought it was great when we were using, I was having to use the snow pipes and be able to take files and put them in yourself and creating the
Yeah.
structures. And even then I thought it was easier, but it's really great to see where they've come in
Oh,
the
yeah.
last 5 years, and how this feature in Snowpark really accelerates the ability to do things like this
I
for
agree. I mean, I remember initially the early days of working with Snowflake, maybe 2016. And I thought, well, these stages, this is really cool. These file formats, this is really cool. But there was a lot of, I'll say, upfront prep that you had to do before you started loading files. And I
right.
didn't, really begrudge them at the time, because it was still, even then, simpler than a lot of platforms. But now
Right.
it's really dead simple. If you're willing to write Java, Python, or Scala, then Snowpark makes all of this so simple.
Yeah.
If we go and look at this file sample, and this is what I mean by fixed width multi-format. So this sample has 3 records in it, and all of the records share the same 2 columns. It doesn't look like 2 columns, but it is, because it's fixed width, meaning the file has a certain number of characters for each column. There's no separator. So they all have a timestamp. Okay, so that goes up to here. And then the next column is their record type. So there's 3 different record types in this file. There's a fin for financial record, SEC for security record, and CMP for company record. And you can see once we get past those first two columns, or this first, we'll say 15 characters, 17, I don't want to count, but after we get past that first set of characters, it's a completely different record type as we go toward the end of the file. So this, again, was very common. This probably looks like absolute bananas to somebody who's relatively new to data engineering today, but we had to solve for this all the time back in the day when mainframes were more common than they are today.
Right. People got very creative in there with how they would store data within
Exactly.
files to get the most out of every bit, right?
That's exactly right. I mean, you think storage was limiting 5 to 10 years ago. It was very, very limiting prior to that. So that is exactly the reason they did this, Keith, was to not waste one single byte.
Yeah, and even I've seen a lot of this, a few years back, I was working with telematics data, right? That's coming off of vehicles. And same thing, they're trying to get as much data off of these little devices, quickly from a vehicle out. And you kind of ran into the same thing, right? It's there's a lot of data there, but they were very creative in terms of how it was, saved and transported over. And so you had to be creative to get it then structured and out of that file.
Exactly. So I want to show you how we would go about. There's a lot of ways to do this. This could be done in SQL with the load command as well. But I really, I'm a developer at heart, so I really love how simple this is in Snowpark. So what I'm doing is I'm defining a single, so here's my schema, right? My struct field. I'm defining a single column, and I'm calling it line. So I'm pulling in the entire line so that I can work with it. This is a common practice. I'm sure many of you out there have done something like this in the past. I had to choose a delimiter, and really you can choose any delimiter that is not in your data. So you can choose some off the cuff sort of characters that you're just positive aren't in your data. I've tested this. There's no delimiter. There's no pipe anywhere in any of the data fields. So that's a safe bet. And then what we're going to do is we're going to use the Snowpark with column function. That allows you to take a data set and add an additional column. So no sub-select required. No, it's just so simple in Snowpark to take where you're at this point in the data frame and add an additional column, add an additional column. So what I'm doing here is I'm adding the column for the timestamp, and I'm adding the column that is the record type using a very simple substring to do that. And then I'm going to create this temporary table that I'm calling Finwire. So let's take a look at what that looks like. And this is what it looks like. So we still have the line, the entire record as a column, but now we've got these two additional columns on the end that give us the timestamp and the record type. And we save that as a temporary table. I could have kept it just a data frame and created another data frame or whatnot, but saving it as a temporary table is good for performance. So we have that. So now I'm able to take that temporary table and slice it up 3 ways for each of these different record types that's in the file. Now I'm only going to show you one. It's the SEC or the security record type, but you would do the same process for each of the additional record types. And of course, there's full samples in the Git repo. So this is me just taking creating a new data frame based on that temporary table. First thing I'm doing is I'm saying only give me the SEC record, the security record types with a .where function. .filter is an alias for .where. They're exactly the same. So if you like that language a little bit better. And then as we go through, we're going to rip apart that line column and start to substring it out into multiple columns, things specific to this record. And then at the end, these columns are no longer relevant to this table. The line we don't need. We've just dissected it down to its parts. And then the record type, we're going to be saving this company record, this company table, which only has the company records in it. So the record type is no longer really valuable either. So let's create that. So the SEC, the security table was created, and then let's show it. So this is what the record type for all of the security records looks like. We have, of course, we have the timestamp. We removed the record type that was SEC, and now we can start to look at, we have symbol. You can tell these are auto-generated. It doesn't look like any stock symbol I've ever seen. And then we see issue types and all of those, numbers outstanding, first trade date, etc. So this is how we do these fixed width multi-file formats. And if you had 5, 10 different record types in a file, then you would create this temporary table that has the entire line in it, and then you'd start stringing out all the relative columns. So from that, I'm going to move on to XML. And so there is a single XML file in the TPC-DI data set. And it's supposed to represent a feed from a customer management system, or what most of us might call a CRM. So I'm giving you a sample of what that file looks like, except I've removed all records from it except one. So this is exactly what a single record feed would look like. And you can see that we have this sort of TPC-DI actions overriding element. So that's kind of like, if you think XML was a way to sort of represent tables in files back in the day, that's kind of the table name. So you could kind of think of the table name as actions. And we're actually going to strip that when we load it. And you'll see that in a minute, because if we didn't strip it, Snowflake would think this entire file was a single record, because that's what it kind of looks like on the going in position. So the first thing we're going to do when we load it is we're going to strip that so that it's each individual action becomes each row. And you can see that what we have here is a combination of elements and attributes. I've got several articles I've written on Medium that walk through a bunch of this, and as I described there's really no hard and fast rule why you might have, why you might have an attribute, that's what these are at the top, versus an element, and that's what these elements are below. It's really, these kind of decisions have to be made today with document databases and NoSQL databases and JSON databases, sort of the best design patterns. There's really nothing different about XML. They just did it many, many years ago. So Snowpark makes it easy to pull attributes and pull elements and to pull nested elements. So that's what the sample looks like. And I've kind of done a hierarchical representation of the entire, of what a single record looks like, using the @ symbol to represent an attribute versus an element. So as we start to look through this, we have an action. An action has a couple of high-level attributes describing it. Inside that action is a customer, and then a customer, again, has some nested elements: name, address, contact info. Contact info has some nested elements around phone numbers, and on and on and on. So, to pull this, what does it look like to do this in Snowpark? And I want to walk through that. So first, like you've seen me do several times prior, we're going to pull this file, we're going to upload it, and then we're going to get a data frame that reads it. And you see the strip outer element. You would most likely be doing that for most XML files, but again, your mileage may vary. And then we're going to use this XML reader to pull the file in, and let's see what we get at the end of that. So what you see, let me scroll up here. What you see is just really the sample we saw above. So, if you were hoping that Snowflake parsed this record and gave you really simple data, it's not the case, unfortunately. It gives you this single column, $1, that has basically the element almost as a variant data type. It gives you the entire XML record, okay? So then we have to start working ourselves to parse that record. And how's that done? Well, it would be nice if we had dot notation like we do in JSON. Unfortunately, that's not the case. So when working with XML and Snowflake, we have to use a combination of the get and the XML get functions. And usually we have to use them in tandem, which can be quite tedious, honestly. So what I've done here is write a bunch of helper functions, and this is why Python or Snowpark in general is so great. I can abstract out this toil from my process and make it quite simple. So I wrote a function, get XML element. I wrote a function, get XML attribute. And again, this notebook is available in the Git repo if you want to dig in. And then I also wrote this sort of one use function, but because I had 3 phone numbers, it seemed worth it. It's going to go and automatically grab all the different elements of a nested of these nested phone numbers and put them together and concatenate it and build me a proper phone number. So what we'll do first is let's load our functions so that they're available to us. And we're going to create a data frame where we do an XML get and pull up some of these nested columns. And then for the remainder of the transformations, I'm just using my helper functions all the way down to make it quite simple. So let's create this table, customer management. And then I'm just going to pull a data frame and show you a few simple some of the elements that might have been a little more challenging, as including that phone number attribute. So you can see that my helper function gave me nice phone numbers all the way down. You can see that my timestamp is being rendered correctly, etc. So this is, at this point we were done loading all the files, right? So we've loaded all the files. But we have this specification that the TPC-DI gave us that is this reference data warehouse and how to, what it looks like and what we should be building as a part of this data set. So I'm going to be building this, and I made the choice to use dbt to build this. Of course, I could have continued with Python, and that would have been a fine choice, but I wanted to use dbt and dynamic tables. So I wanted to use dynamic tables, which is a new feature. And an interesting thing as I started going down this road was when you Google dbt dynamic tables, it seems like these two features are at odds. It seems to be like a lot of the community thinks dynamic tables or dbt. And it's just really not that simple. So this is not really, is it simply that dynamic tables is now some sort of a replacement for dbt? And I don't think it is, right? So if you think about building a DAG, whether it's dynamic tables or regular tables, there's a lot of information necessary to do that. So even if I'm going to create a whole DAG or a whole directed acyclic graph of all of my data pipelines, I need to understand what order they're created in. So even though Snowflake is going to take care of refreshing the data, I still need to understand the relationships and the dependencies. And unless I want to write a custom script with with the order in which I need to create everything, then dbt is still a great way for you to manage the deployment of your dynamic tables. So how hard is it to enable dynamic tables in dbt? It's just dead simple. So be on version 1.7. I know it's 1.7x that dynamic tables come in, and I believe it's 1.7.0. And then we can just start. We have this new materialization type called dynamic table. And then we need to set our warehouse and our lag. So one of the nice things here is I've created a bronze, silver, gold sort of data warehouse structure, data lake structure. And what I've said here is I don't really have an expected SLA for my bronze. It's not used. Nobody really cares about bronze. It's a lot of raw data. So basically, I just want to declare the lag for that or how often this data is refreshed to downstream. That means don't refresh this unless something downstream from me needs it. And that's really great. And then we go to Silver. I've said Silver, that's more sort of operational reporting, you would say. 10 minutes. I need that really, really often. And then Gold, 20 minutes. So, let's take that in for a minute. We can start thinking about our downstream tables, our downstream data assets in terms of SLAs. We can declare our SLAs as part of our pipeline and let Snowflake handle it. Not worry about, does my orchestration tool, how long does the job take? How often do I need to schedule it to be, to not breach my SLAs? Just simply declare them. And this is what's really great. So I want to take a look at this. We're going to do a DBT build. And, it's not that different from what you'll see with a DBT build without dynamic tables, except, as you can see, we're creating or replacing a dynamic table. So this is going to take about another 30 seconds, Keith. I'll see if you got any quick questions for me.
No, I think this is, we're talking about loading the this data set, but what I'm also getting out of this is also information on just how to handle some of these file types that you might be running into in your organization. So though we're using this to load data, the fact that this data is coming in a variety of different types of formats and structures, or even like you're doing now to handle it, is it's bringing in some educational aspects on just how to handle these types of data sets, or even how to load these data sets. So be
Yeah,
up and beyond just the date getting to use the data, how to leverage these variety of formats. And
yeah, absolutely. And I could have continued down the Snowpark path to create all these downstream tables. But really, when you start looking at using all the features of Snowflake and not sort of, pushing yourself into a corner, this is the easiest way to build downstream tables. So now we use our code, we get our data loaded, we have some processes for that, but then let Snowflake take over. Let Snowflake, autopilot sort of take over and get the rest of it built. So we have all of our tables loaded, all of our downstream tables, and now Snowflake's going to keep those in sync for me. They're going to keep them updated. And then, so another feature that DBT has that may be valuable, even if you're using dynamic tables, is tests. So there's no built-in feature in Snowflake to write tests. Obviously, you could write your own. You could probably create some procedures, some sort of a testing framework. Maybe you would do that in UDFs or something like that. But maybe use DBT, and this is quite easy. So I've created a test as part of the building of the dynamic table. I can run a test, and I want to make sure that the trade table is unique. I could also schedule it periodically to run. So I just want to run my tests every 3 minutes, 6 minutes, 8 minutes. Even though Snowflake is keeping my data, my tables up to date, I can still use DBT to test. And then I want to show you something real quick, and let me change. I'm just going to change what I'm showing, and real quick, bear with me.
no problem.
You see that, Keith?
Yep.
Awesome. So once these dynamic tables have been created and they're up to date, we can see them here when we come into Snowflake. Do I need to zoom in, or is that pretty good?
I think it's good.
Okay, good. So now we see all of our dynamic tables, and I want to go straight to one of our final fact tables called fact watches. And this is one of those dynamic tables. And I want to show you what's really interesting here is this graph, okay? So once all of our dynamic tables are created, hopefully that's zoom is reasonable. There we go. You can see that Snowflake is aware of all of my upstream dependencies. It's aware of my graph. It's aware of all these relationships. However, it's only aware of these after they've been created, not before. So that's where DBT can still come in for you as a way to deploy an easy development tool. Developers don't have to keep, hitting friction because they're creating new dynamic tables and there's dependencies that haven't been created. Just use DBT, which is really good for that. And with that, um, that'll wrap it up for what I plan to show you, Keith.
No, this was great. This was fantastic. I really enjoyed it. I'll switch back to people can see our pretty faces. Um, no, like I said, I found that really fascinating to show how you use the variety of tools. One, we started with how to get this data in, but then how to handle a variety of formats of data structures, how to leverage Snowpark to do that. You even touched on dynamic tables and then how to use DBT. So I found that very informative. So I greatly appreciate
Excellent.
it. So
I mean,
um,
use all the tools, right? Use
right,
all the things that don't get caught up on one, on one utility or one tool or one library or one SDK. By all
right,
means, if you're comfortable with that, you wanted to do this whole thing in Snowpark, it's absolutely possible. But there
great,
are right features, right time. And Snowflake has so many of them that,
yeah.
let's pick and choose and what makes sense.
Absolutely. Well, again, I greatly appreciate you having me on. I know you brought up some blogs. We'll make sure for everybody. We'll put in the comments below, links to your Git. We'll add your blogs and where people can find you on LinkedIn. But again, thanks for joining us,
Hey, thanks for
and
having me.
thanks everybody for watching this episode. And we'll look forward to seeing you all next time.
Yeah,
Bye,
look
everybody.
look in the feed. There's a bunch of other good videos that came before me, so make sure you go check out all those as well.
Great. Thanks, everybody. We'll talk to you later. Bye.